Everyone says AI will take away jobs, but what no one told you is how fast AI is already changing the jobs we do every day. Think about it. The emails that reply automatically, the camera that blurs your background perfectly on a video call, or the app that recommends what to watch next, all of that is powered by AI. You've been using AI for years, just never realized it. So here's the problem. Most people try to learn AI the wrong way. They open a textbook, see words like neural networks, NLP, machine learning, and quit before they ever do anything real. That's not learning, that's drowning. You don't need complex math. You don't need to code. You just need to see how AI actually works and where it fits into real life. Once you get that, everything clicks. AI stops being scary and starts feeling innovative. In this masterclass, I'll simplify everything. We'll break down what AI really is, how it evolved, the types of AI models, and most importantly, how you can use this knowledge to get ahead, build projects, and prepare for the jobs that are being created right now. This isn't a lecture. It's a roadmap you can start using today. Everything I'm about to show you comes straight from how real companies use AI, like Google, Microsoft, and startups building products that ship every week. You'll see real-world examples, not just theory. Because this is a practical learning session. So stay with me till the end, because I've got something you'll actually use. A complete AI career roadmap, and a list of free tools you can start using. And by the time we're done, you will just know AI. You'll use it better than 90% of its daily users. Ready? Let's start. Section 2. What is AI? Now that you know why learning AI matters, let's start with the real question. What is artificial intelligence? People throw the word around like confetti. AI this, AI that. But when you ask them what it means, most of them freeze. So let's break it down. Simple definition of AI. AI is a technology that can think, learn, and make decisions almost like a human. Not magic, not some sci-fi, just systems designed to understand, reason, and act. Let's have a look at its examples. Whenever your phone unlocks just by recognizing your face, that's AI. Or when your camera adjusts the lighting perfectly for your selfie, that's AI doing its quiet magic. So, in short, artificial intelligence is human-like decision-making, but done by machines. Key abilities of AI. What makes AI actually intelligent comes down to 4 main abilities. First is learning. AI learns from data, just like we learn from experience. That's how Netflix figures out what you'll probably want to watch next. The second one is reasoning. It uses logic to make decisions, like how Amazon recommends products you didn't even know. Third is perception. It understands visuals, sounds, or language. Think of how Siri understands your voice. And finally, the fourth is action. AI doesn't just analyze, it acts. Whether it's a self-driving car steering on its own or an AI bot scheduling your meeting. So now that you know what AI can do, let's see how it actually does it. How AI works. Every AI system works in a cycle, starting from input, leading to processing, then output, and lastly, feedback. It takes in data such as text, images, and speech. Then processes that data through patterns it has learned, models built from millions of examples. It gives an output as a prediction, a decision, or a creative piece. Lastly, it checks the results and learns again. That's the magic loop. And every time the loop repeats, the AI gets sharper. So the secret isn't in how big the AI is, it's in how fast it learns and how good its data is. Why AI matters. Now, why does all this matter for anyone learning or working right now? It matters because AI is no longer a tool for tech people. It's a language of modern work. Every company is racing to integrate it. Every creative field is being redefined by it. And those who understand how it works, even at a simple level, are the ones shaping the future, not chasing it. You don't need to build AI models. You just need to know how they think so you can use them to build your ideas. Because in 2026 and beyond, AI won't replace people, but people using AI will replace people who don't. Now that you know what AI really is, let's rewind a bit and see how it all began. Because to understand where AI is going, you first need to know where it came from. Section 3, Evolution of AI. The early beginning, 1950s. It all started with one simple question: can machines think? In 1950, Alan Turing asked that question in his paper, Computing Machinery and Intelligence. He proposed the Turing test. If a computer could talk so well that you couldn't tell it apart from a human, then it was intelligent. That idea changed everything. It planted the seed for what we now call artificial intelligence. One question started a revolution, and that question still drives AI today. The birth of AI, 1956. As time passed, at a summer workshop in Dartmouth College, John McCarthy and a few colleagues gathered to explore one idea. Can we make machines that think like humans? That's where the term artificial intelligence was born. 1956 is the official birth year of AI. Those early systems were logical and rule-based. They could reason, solve puzzles, and play basic games. It was the dawn of a new field. Small steps, but groundbreaking. The 1960s to 1970s. First AI programs and the first AI winter. The 60s brought excitement. Programs like Eliza could mimic human conversation. Sherdlu could understand simple commands in a virtual world. People started believing machines would soon think like them. But reality hit hard. Computers were slow, memory was tiny, and progress stalled. That slowdown became the first AI winter, a period where funding dried up and enthusiasm froze. But every winter ends. The 1980s, the expert systems era. The 80s reignited hope. This was the age of expert systems, programs built on if-then rules that mimicked decision-making. Systems like Mycin, used for diagnosing infections, and XCon, used by businesses, showed that AI could actually help professionals make better choices. But there was a catch. These systems couldn't learn. They only knew what you told them. No data, no growth. So once again, progress slowed. The 1990s, the rise of machine learning. Then came a breakthrough. Instead of programming machines to follow rules, we started teaching them to learn from data. That is where machine learning evolved. In 1997, IBM's Deep Blue made history by defeating world chess champion Garry Kasparov. It was a global moment, the first time a machine outplayed a human. AI wasn't just following instructions anymore. It was thinking strategically. And beneath the spotlight, something even bigger was brewing. Early speech recognition, handwriting analysis, and pattern detection. The groundwork for what would soon explode. The 2000s to 2010s, the deep learning revolution. Data got bigger. Computers got faster. And then came the spark, neural networks. By 2011, IBM Watson shocked the world by winning Jeopardy! In 2012, the ImageNet breakthrough taught machines to truly see. AI could recognize faces, understand language, and describe the world in pixels and words. From 2015 onward, voice assistants like Siri, Alexa, and Google Assistant entered our homes. AI was no longer hiding in labs. It was part of our daily lives. The machines were learning fast, and this time they weren't slowing down. 2020 to 2024, the generative AI era. Then the biggest leap yet, AI stopped just recognizing things and started creating. ChatGPT, DALL-E, Midjourney, Bard, and Gemini are the tools that could write, draw, compose, and code. We entered the generative AI era, where anyone could turn an idea into text, image, video, or music instantly. Work, education, and art changed forever. AI didn't just get smarter, it got creative. 2025 and beyond, agentic and hybrid AI. And now we stand at the edge of a new chapter, agentic AI. These aren't just tools, they're agents that can plan, reason, and act on their own. Think agentic tools like AutoGPT, Microsoft Copilot, and Baby AGI that use AI systems that can take goals, make decisions, and complete tasks. They combine the creative power of Gen AI with the decision-making of agentic models, what we call hybrid AI. From self-driving cars to fully autonomous work assistants, AI is no longer just reacting, it's doing. And understanding how these models work together is the key to using AI smarter. Now that you've seen how far AI has come, let's explore how it actually learns. Because once you understand that, you'll know exactly how to use it to build real projects using different types of AI models. Section 4. Types of AI models. Discriminative models, the foundation of AI. This was AI's first big step. Discriminative models don't imagine or create, they recognize and decide. They're like a sharp-eyed detective, spotting what's real, what's fake, and what's worth attention. They work by learning patterns and drawing boundaries, like this. When your email automatically separates genuine messages from scams, that's a discriminative model at work. When your bank system instantly flags a suspicious transaction, that's another example of it. Or when your photo app sorts your pictures by people or objects, that's pure pattern recognition of a discriminative model. This model doesn't dream or create. It classifies, compares, and chooses. It's the foundation that taught machines how to see differences. Generative models, the creative leap. Once AI learned to recognize, the next question was obvious. Can it create? That's where generative AI steps in. Unlike earlier models that simply identified or categorized data, generative AI takes everything it's learned, language, visuals, sound, structure, and uses it to produce something entirely new. And tools like ChatGPT can write a story that's never existed before. And Midjourney or Leonardo AI can paint a world that only lived in your imagination. Hum a few notes, and Suno or Udio can turn it into a full song. And with Runway, even a single line of text can become a complete video scene using Gen AI. Generative AI is where machines stopped just understanding reality and started creating their own version of it. If discriminative AI understands the world, generative AI adds to it. It's not copying, it's imagining. Agentic AI, the thinking machines. Now we've entered a new era where AI doesn't just wait for your prompt. It plans, reasons, and acts on its own. That's where agentic AI comes in, the next evolution of intelligence that doesn't just assist you, it works with you. Imagine this. You tell your AI, I want to launch a personal website. It doesn't just give you steps. It builds the plan, writes your bio, designs the layout, finds visuals, and even suggests what tools to use. That's not automation, that's collaboration. Or think about your workday. An AI assistant reads your emails, prioritizes what matters, schedules meetings, drafts replies in your tone, and reminds you what's next, all without you lifting a finger. That's not futuristic. It's already happening with tools like Microsoft Copilot, Lindy AI, and Personal AI. In short, agentic AI acts like a digital teammate. It doesn't just follow commands, It understands intent and gets things done. This is the closest we've come to AI that doesn't just think for you, it thinks with you. Hybrid models, the future of intelligence. Now, imagine everything we just talked about AI that can recognize, create, and act, all working together in one seamless system. That's hybrid AI. It's the next evolution, where every part of intelligence connects like computer vision, the understanding of LLMs, and the decision making of agentic AI. Think about tools like Notion AI or Microsoft 365 Copilot. They don't just summarize or write, they analyze your notes, generate reports, design slides, and even suggest your next task. That's multiple AIs, language, logic, and reasoning, working together in real time. Or imagine that you're planning a trip. You tell your AI assistant where you want to go, and it finds flights, books the hotel, creates your itinerary, and even adds reminders to your calendar. That's not one AI, that's a whole system of AIs thinking and acting together. Hybrid AI is where creativity meets autonomy. And that's when AI stops being just a tool. It starts becoming an intelligent collaborator. Section 5, Structure of AI. Now that you know what AI can do, it can see, talk, plan, even create, let's take a look at how it actually works underneath. What's really happening inside these systems that makes them so smart? Let's break it down, step by step. 1. Machine learning, the core engine of AI. The first one is machine learning. It is how computers learn patterns from data and make decisions, not by memorizing, but by understanding. You just feed data in. The machine understands it, finds patterns, and learns how to make predictions. That's it. When Spotify builds your daily mix playlist and it somehow fits your vibe perfectly, that's machine learning, understanding your music taste. And when a job portal recommends openings that actually match your skills, that's ML learning what kind of roles interest you. It's just experience, repeated thousands of times faster than we can. Deep learning, the brain inside the machine. Now imagine taking that learning process and giving it depth. It's inspired by how our own brains work. In your brain, neurons connect. One fires when you see color. Another reacts to shapes. Another recognizes a familiar face. Together, those layers of neurons help you understand the world. Deep learning works the same way, just digitally. Each artificial neuron looks for patterns. One layer spots edges in an image. The next identifies objects, and another understands context. Layer by layer, it goes from raw pixels to full meaning. That's why your phone camera adjusts lighting perfectly even in tricky conditions. Why Google Maps predicts traffic before it even happens. Or why medical AI can detect early signs of disease from an X-ray. All thanks to deep learning, quietly recognizing patterns we can't even see. Deep learning is what turned AI from a calculator into something that listens, watches, and understands, almost like it's thinking. 3. Natural language processing, how AI understands us. Now let's talk about communication. Natural language processing, or NLP, is what helps AI understand us, our words, questions, tone, and meaning. It's how your phone's keyboard predicts your next word before you even type it. And it's how search engines know what you mean. Like when you type best laptop for travel, it understands you're not just asking for laptops, but lightweight ones with good battery life. 4. Computer vision, how AI sees the world. If NLP is how AI listens, then computer vision is how it sees. This is the tech that lets machines look at images and videos and actually understand them. It teaches AI to identify objects, people, and surroundings, almost like a pair of digital eyes. 5. Large language models, the power boosters. Now this is where things truly accelerate. Large language models, or LLMs, are the power boosters behind today's most advanced AI. They're trained on massive amounts of text, everything from books and articles to code and conversations. And they learn context, meaning, and flow. They're built on something called transformer architecture, a breakthrough that allows AI to understand not just words, but relationships between them. That's why tools like ChatGPT, Claude, Gemini, and Llama can write essays, debate ideas, and hold human-like conversations. 6. The full picture, how it all connects. So let's put it all together. AI isn't one big machine, it's a collection of layers, each doing its part. Machine learning finds the patterns. Deep learning handles the complex stuff we can't easily explain. NLP helps AI understand our words, and computer vision helps it see the world around us. Then come large language models, the brain that ties it all together, making AI sound human, think creatively, and respond in context. Everything you see, from smart recommendations to creative AI tools, comes from these layers working in harmony. Section 6. Machine Learning Deep Dive. Now that you know how AI is structured, let's start with its core, machine learning, the technology that taught computers how to learn. 1. Machine learning. Teaching computers to learn. Machine learning is how computers learn patterns, not by memorizing, but by understanding. You don't write every rule. You just feed data, and the system figures out the logic itself. Think of it like this. You train a model with thousands of Nike shoe images and details, including color, logo, shape, price, and reviews. At first, it knows nothing. But as it studies more examples, it learns the patterns that make a Nike shoe what it is. So when new data comes in, it predicts. That's a Nike. It works the same way in ride-sharing apps like Uber or Lyft. They feed the AI millions of past trips, distance, traffic, weather, and demand. So now, when you book a ride, it can predict your fare before the car even starts moving. It's not guessing, it's learning from experience. And that same idea applies everywhere. Different kinds of learning for different kinds of problems. 2 types of machine learning. Machine learning comes in 3 major types. Each one learns differently. The first one is supervised learning. This one is simple. You give the AI examples with the right answers, and it figures out the pattern, like sorting emails into spam or not spam, or predicting house prices based on past data. Every time it's wrong, it learns why, and gets a little better. That's how AI learns from us. The second one is unsupervised learning. Now this one's different. Here, the AI doesn't get any answers. It just gets data and tries to figure things out on its own. It starts spotting patterns, like grouping customers with similar shopping habits or finding songs that people usually listen to together. It's like exploring a new city without a map. You start noticing connections naturally. The third type of ML is reinforcement learning. This is where AI learns through experience, by trying, failing, and improving over time. It's how delivery robots learn to navigate streets safely, or how self-driving cars get better at making split-second decisions. Every turn, stop, or mistake becomes feedback. The AI gets a little smarter each time, learning what to do and what not to. It's like teaching a kid to ride a bike, wobbly at first, but eventually, balance becomes instinct. Machine learning is where every smart system begins. It learns from examples, discovers hidden patterns, and improves through experience. Together, these 3 ways of learning make AI adaptive, able to think, evolve, and get better, one data point at a time. Section 7. Deep learning, the human brain of AI. Deep learning is what made AI feel human. It's how machines started recognizing faces, understanding voices, and even creating art. This is the breakthrough, that turned algorithms into something that could see, listen, and imagine. 1. Deep learning. Deep learning is built on something called artificial neural networks, which are layers of digital neurons that process information just like we do. When your brain sees an image, it picks up light, shapes, and patterns, layer by layer, until it realizes that's a face. Deep learning does the same thing, but inside a computer. 2. How it works. Every deep learning model works through layers. The input layer takes in data like a photo, a sound, a line of text. The hidden layers analyze it again and again, each time seeing something deeper: shapes, edges, tones, meanings. The output layer gives the result: a face recognized, a voice understood, a sentence completed. Each layer learns something different, like peeling an onion or zooming in on truth. The deeper the layers, the smarter the understanding. 3ML versus DL, the simplified comparison. Alright, so what's the difference between machine learning and deep learning? They're both ways for AI to learn, but they work very differently. Machine learning handles small or medium data, learns from features we define, trains faster, and runs easily on normal CPUs. Deep learning, on the other hand, needs massive amounts of data, learns patterns automatically, takes longer to train, and depends on GPUs or TPUs for heavy computation. Precisely. Machine learning is like teaching with flashcards. Deep learning is like raising a mind that learns to think on its own. Section 8. NLP. How AI understands us. Now that AI can think and learn, the next step is making it understand us. That's where NLP comes in. 1. Definition. Natural language processing is what lets AI read, write, and talk in human language. It's how machines go from code to conversation, interpreting your words, figuring out meaning, then crafting a response. 2 examples. Let's make this real. Stuff you see every day. ChatGPT understanding your prompts and giving meaningful replies. Google Translate converts entire sentences between languages. Alexa or Siri listening to your command, play music, set alarm, and doing it instantly. These look seamless, but behind each action is a layer of NLP parsing, choosing, and generating. 3 one-liner takeaway. So NLP is what gives AI a voice. It's how machines understand what we say and what we mean. Section 9. Computer vision. How AI sees the world. If NLP is how AI understands words, computer vision is how it understands image. 1. Definition. Computer vision enables machines to see, analyze, and make sense of visual data, such as photos, videos, live camera feeds. It's the branch of AI that turns pixels into meaning. It doesn't just detect shapes, it interprets what's in them. 2. Examples. Here are a few moments you use computer vision without realizing. Medical AI detecting tumors or abnormalities in X-rays or MRIs. Retail systems tracking product placement or missing inventory. Each of these is a version of machine vision, turning raw visual input into actionable insight. Section 10. LLMs, the engine behind modern AI. Everything we've learned so far, from machine learning to NLP to vision, comes together inside one system, the large language model. 1. Definition. Large language models are massive AI models trained on billions, sometimes trillions of words. They learn language deeply, not just individual words, but context, nuance, and meaning. These models can generate text, answer questions, summarize, translate, write code, and even reason. Think of them as the brain that understands and speaks human language. 2. Examples. You already live with LLMs every day. ChatGPT, Gemini, Claude, Llama, all powered by LLMs. They can write essays, carry conversations, generate code, explain complicated ideas. They don't just repeat patterns, they weave meaning. 3. One-liner takeaway. LLMs are why AI feels human. They don't just process words, they grasp meaning. Section 11. AI Career Roadmap. Learn, build, and get hired. 1. Start with the essentials. Before you jump into tools or fancy coding tutorials, just focus on understanding what's actually going on behind AI. Learn the basics, including AI, ML, DL, NLP, and CV. Understand how they connect, not just what they stand for. You don't need to rush. Take your time with it. Use the tools you already have, like Play and ChatGPT, explore datasets on Kaggle, test prompts in Gemini, try weird ideas, see what breaks and what clicks. When you sense the pattern, that becomes your foundation. 2. Build something, anything, because knowing without doing, that's just theory, and theory never changed anyone's life. So pick one idea and start building it. You don't need something big or complicated, just start small. You can even build something simple, like a resume checker using ChatGPT, or maybe an AI content planner that helps you stay consistent, or a tiny chatbot that answers basic questions. The point is, just do it. Every project you make is proof that you're actually learning, proof that you're not just watching, you're building. And here's the cool part, each thing you create teaches you something new. The more you build, the more confident you get. And before you even realize it, your projects start speaking for you, louder than any resume ever could. Learn the tools that actually matter. You don't need to learn everything, you just need to learn what matters right now. If you're on the coding path, stick to the essentials, such as Python, TensorFlow, and PyTorch. Or if you're going for a no-code or hybrid path, focus on ChatGPT, Copilot, Notion AI, or Runway. Don't chase every new thing that pops up online. Pick a few tools and go deep. Learn them so well that using them feels like second nature. That's what makes you valuable. Not knowing everything, but knowing a few things really well. Because the people who can blend coding and AI tools are the ones who'll stand out in 2026. Show what you build. Also, whatever you make, don't keep it to yourself. Share it to the world. You can post it on LinkedIn, GitHub, or even as quick YouTube shorts. Also, talk about what you built, what went wrong, and how you fixed it. Because people don't want perfect things, they want real. Take an example. When recruiters or hiring managers see you experimenting, failing, and improving, they see growth. Your projects tell your story. So don't hide them. Share what you're learning, what worked, and what didn't. That's how people notice you, and that's how opportunities find you. But even more than that, it changes how you see yourself. Once you start doing this, you're not just learning AI anymore. You're living it, the mindset that changes everything. Let's be real for a second. AI isn't here to take your job, but someone who learns to use it better, yeah, they might. So don't look at AI as competition. Look at it as a tool, one that can multiply what you're already good at. You don't need to be some coding genius or math expert. You just need curiosity, the kind that makes you ask, what if? Or you need consistency, the kind that keeps you coming back even when it's frustrating. And lastly, you need courage to build, to fail, and to try again. So keep showing up, keep learning, and keep creating. Because every little thing you do, it all adds up. And one day, without even realizing it, you'll become the person others turn to for guidance. Not because you knew everything, but because you kept going when most people stopped. If you're still here, that already says something powerful about you. Most people talk about learning AI. You're actually doing it. You didn't just watch this. You stayed, you learned, and you thought, yeah, I can do this. And that's exactly what this masterclass was about. Not memorizing fancy terms, but understanding how AI thinks, learns, and creates opportunity, so you can do the same. Now, don't wait for the perfect time. There's no such thing. Pick one small project. Try one new tool. Do one thing today that in the future you will thank you for. You won't build something amazing overnight, and that's okay. Every little thing you create gets you closer. Because AI isn't here to replace us, it's here to give you superpowers if you're willing to learn how to use them. So start, build, experiment, and keep moving. Because the people who start now are the ones who will shape what comes next. If this masterclass helps you see AI differently, hit like, drop a comment, and subscribe to AI Chief, because next we're going even deeper, from learning AI to creating with it. And if you want daily updates about the latest AI tools, news, and tutorials, join our free weekly newsletter. The link is in the description.